Hello and welcome to our next video on ASME B31.3. In the last video, we have talked about the chapter 1, which was scope of this code. In this video, we are going to talk about design requirements and design criterias. Again, this video series is generally helpful for the people who are studying for AP ICP examinations and for the people who just want to learn about process piping systems. But if you're talking about AP ICP examination, design requirements are not that important. Obviously, this chapter is important because you just want to know about the piping system, how they are made. But in this case, the design requirements are generally not that important because at the end of the day, we are not making a new piping system. We generally have to deal with the piping that are already in service. So in this case, the entire design process is not that important because for this we'll generally have a designer. But some things have to be figured out, and some things are going to be the similar requirements for in-service systems, such as if you want to identify the thickness requirements, if you want to identify that what should be the weld requirements. All of these things are going to be generally derived from the original construction code, which in this case is going to be the ASME B31.3 code. Okay, so the conditions and criteria. Design conditions, you have qualifications of the designer. The designer is a person in charge of engineering design of a piping system and shall be experienced in the use of this code. So a person who is designing is going to be responsible for the entire design of the piping system. They shall be experienced in using this code, and as per the requirements laid down by this code, they'll be making up a design for a piping system. So generally the person would need some of the criterias that are fulfilled. So basically the person should be completing some engineering degree with these jurisdictions. They should be having a professional engineering registration. They might be accredited as engineering technicians or associate's degree with at least 2 years of study and 10 years of experience. And all of these, at least one of these following things are to be fulfilled for the person to be considered for the designing requirements of ASME B31.3. Next is design pressure, one of the very important things for us. So the design pressure of each component in a piping system shall not be less than the pressure at the most severe condition of the coincident internal or external pressure and temperature expected during service, except as provided in a paragraph 302.2.4. That means the design pressure, whatever the design pressure is basically an assumption. So design pressure is an assumption that a designer takes while designing the process piping system. This design criteria, this design pressure criteria is generally going to be the initial design pressure because of which you are making the piping system. So let's imagine the maximum pressure on the piping system that we are going to make is going to be 500 psi. In that case, we'll be designing the piping system while taking this 500 psi pressure as the requirement, and this 500 psi is now going to be the design pressure because for this pressure we are doing the design. Okay, the most severe condition is that which results in greatest required component thickness and highest component rating. So generally a worst case scenario is generally taken into consideration. So we'll generally have a factor of safety for either components. So generally when taking the design pressure into consideration, the greatest amount of pressure needs to be considered as design pressure, and accordingly the things are going to be designed as per the design pressure requirement. Next is required pressure container or relief. The provision shall be made to safely contain or relieve any expected pressure to which the piping may be subjected. Piping not protected by the pressure relieving device or that can be isolated from the pressure relieving device shall be designed for at least the highest expected pressure. Design temperature, again the design temperature is the temperature for which our piping system is going to be made. Design temperature again can be both of these things. You can have a minimum temperature range also, we have a higher temperature range also. In establishing the design temperature, consider the least fluid temperature, ambient temperature, solar radiation, heating or cooling medium temperatures, and the applicable provisions of 301.3.2, 301.3.3 and 301.3.4. That means we also have to consider, while considering the design temperature, is you have to consider that what is the fluid temperature inside the pipe. If it's a cryogenic service, then the fluid temperature is going to be very less. what is the ambient temperature, what is the surrounding temperature. Solar radiation, if the pipe is external from the shop, if it's in the environment, then solar radiation also needs to be considered. If it's a in plant pipe, or if it's a pipe that is inside a workshop, then it generally not needs to be considered for solar radiation. Heating and cooling medium temperatures and the applicable provisions of uh, these paragraphs. Design minimum temperature. The design minimum temperature is the lowest component temperature expected in service. The temperature may establish special design requirements and material qualification requirements. Why this is important? Because in most cases, if you're talking about steel, steel is a BCC structure. It's a body cubic centric structures. So body cubic centric structures have a flaw in them. So body cubic centric structures are generally going to be more brittle when the temperature is going to be low. And as the temperature goes on increasing, their behavior changes from from brittle to ductile at higher temperature ranges. So at low temperatures, the BCC structures, generally steels, are going to behave more brittle, and at high temperature they are going to be behaving more ductile. The transition between the brittle to ductile behavior happens. This is known as ductile to brittle transition temperature. I don't want my piping to be brittle, because if it's brittle, then instead of bending or deforming, it would burst, and it is going to lead into catastrophic damages. Okay, so that's why these temperature requirements are going to be important. If the temperature requirement is very low, then a material needs to be changed, which is I generally can select a material that is going to be more resilient to the temperature ranges that it is going to be subjected to. For uninsulated components, for fluid temperatures below 65 degrees Celsius, the component temperature shall be taken as a fluid temperature unless the solar radiation or other effects result in the higher temperature. For fluid temperatures 65 degrees and above, unless a lower average wall temperature is determined by heat or heat transfer calculations, the temperature for uninsulated components shall be no less than the following values: valves, pipe, lap tanks, weld fittings, and other components having a wall thickness comparable to that of a pipe, that is 95% of the fluid temperature. Flanges except lap joint, including those fitting and valves, 90% of the fluid temperature. Lap joint flanges 85% of the fluid temperature, and bolting is 80% of fluid temperature. These are generally the temperatures for different attachments or different spools that you are different attachments that you are going to attach to your main piping system. So main piping system will generally be considered as the 100% of the temperature, and all the attachments are generally going to be lower than that. Externally insulated pipe, internally insulated pipes, ambient effects, cooling, effects of pressure, fluid expansion effects, atmospheric icing, low ambient temperature services, dynamic effects. Dynamic effects are basically dynamic loading that is going to happen on your equipment. So you can have impact, you can have wind. If there is a high wind velocity that is flowing, it is going to be subjected, your pipe is going to be subjected to various kinds of vibration. If there is an earthquake, then also your piping can be subjected to various kinds of vibration. So in most cases, if it's an earthquake zone, then it is going to be a mandatory requirement that you also have to take earthquake considerations while designing the piping system. If it's not an earthquake zone, still the requirements of earthquake are generally going to be taken into consideration for avoiding any unexpected failures. Vibration can happen due to fluid that is flowing inside the piping system, or by some other equipment that is attached to the piping system. Discharge reactions. Next is weight effects. Weight effects can be two things. The live effect is going to be the effect of the fluid that is going to flow inside the piping system, and dead loads. Dead loads are the load of the piping itself, so it's self weight. Okay. Thermal expansion and contraction effects, effects of support, anchor, terminal, and movement, reduced ductility effects. So harmful effects of reduced ductility can be taken into account in the design of the piping. The effects may, for example, result from welding, heat treatment, forming, bending, or low operating temperatures, including the chilling effect of the sudden loss of pressure on a highly volatile fluid. Low ambient temperatures expected during operation shall also be considered. Next is cyclical effects, air condensation effects, design criteria. So first design criteria, generally all of these things we have taken into consideration. The next criteria is going to be the pressure temperature design criteria. Listed components, okay. So listed components not having specific ratings. Some of the standards for fitting that is given in table 326.1 state that the pressure temperature rating are based on the straight seamless pipe. Such fitting shall be rated as calculated for the straight seamless pipe with same allowable stresses as the fitting and the nominal thickness corresponding to the wall thickness or class designation of the fitting. Less applicable allowances and considering the manufacturing tolerance for fitting and pipe. For components with straight or spiral longitudinal seam welded seam joints, the pressure rating as determined for the seamless pipe shall be multiplied by the weld joint reduction factor, that is W, as defined in the paragraph. So there is a joint category factor that is given by W. It is given in a table. Accordingly, you can select it from the table and you can compare it with the seamless piping condition. Other listed components are not addressed. Unlisted components, the material shall comply with paragraph 323. Designer shall be satisfied that the design is suitable for the intended service, and the pressure temperature rating shall be established in accordance with the rules of paragraph 304. Allowance for pressure and temperature variation. So there can be a design criteria where you are going to take design pressure, you are going to take design temperatures, but still there can be a scenario where this design temperature might exceed, or this temperature limitation might exceed due to some unforeseeable circumstances, due to some overpressure conditions. All of these things are also taken into consideration. So generally a designer will work with some factor of safety. So let's imagine if the design pressure is 500 psi and if the factor of safety is 1.5, then generally the piping is going to be rated for 750 psi, but the working pressure is going to be 500 psi. It is going to be something like this. So occasional variation of pressure, temperature or both may occur in a piping system. Such variation shall be considered in selecting a design pressure and design temperature. The most severe coincident pressure and temperature shall be determined the design condition unless all of the following criteria are met. The piping system shall have no pressure containing component of grey iron or other non-ductile material. Circumferential pressure stresses shall be based on the minimum pipe wall thicknesses and less allowance and shall not exceed the yield strength at the given temperature. Combined stresses shall not exceed the limit established in paragraph 302.3.6. The total number of pressure limitations variation above the design condition shall not exceed 1000 during the life of the piping system. In no case shall the increased pressure exceed the tested pressure under the paragraph 30345 of the piping system. Occasional variation of above condition shall remain within one of the following limits for the pressure design. The subject to owner's approval, it is permissible to exceed the pressure rating or the allowable stress for the pressure design at the temperature of the increased condition by not more than 33% for no more than 10 hours at any one time and no more than 100 hours per year, or 20% of or no more than 50 hours at one time and no more than 500 hours per year. So these are the variations that are given. It should not exceed these variations. Sometimes it can exceed, but that exceedance shall also be under these variables. And all of these things are the criteria that are given. These are to be considered by the designer while designing the piping systems. Again, there are going to be something that are known as quality factors. So quality factors are going to be basically, you can say, efficiencies factors for your casting systems and piping systems. There are tables that are given which we can use for determining these. So the allowable stresses defined in B and C shall be used in design calculation unless modified by the provisions of this code. Tension, the basic allowable stress S in tension for the material listed in table A1 and A1M. So A1 and A1M is basically appendix 1 and appendix 1M, and design stresses S for bolting material listed in table A2 and A2M, where determined in accordance with paragraph 302.3.2. In equations elsewhere in the code where the product SE appears, the value S is multiplied by the quality factors. So quality factors are going to be either for casting quality or for welded quality. So casting quality factor, that is EC, are defined in paragraph 302.3.3 and tabulated for various material specification in table A1A for various levels of supplementary examination. Longitudinal weld joint factor EJ are as defined in 302.3.4 are tabulated for various material specifications. Next is basis for design stresses. So different design stresses for different materials. Casting quality factor. So the casting quality factor is defined herein shall be used for casting components not having pressure temperature ratings established by the standards in table 326.1. So these are casting quality factors. Some notes are given here. So note 1 is going to be, the factor is going to be 85%. Note 1 is machine all surfaces to finish of 6.3 micrometers roughness. So if the casting has a machine surface and the finish is less than 0.63 micrometers, then the casting quality factor is going to be 0.8. And something like this, you can identify casting quality factors from table 302.3.3c. Same thing we have is something known as welding quality factors. So basic quality factors are the weld joint quality factor EJ are tabulated from table A1B and are basic factors for straight and spherical spiral helical seam welded joints for pressure containing component as shown in table 302.3.4. Increased quality factors also indicates the higher joint quality factor that may be substituted for once in table A1B for certain kinds of weld if additional examination is performed beyond the required by the product specification. So these are acceptance levels for casting. These are joint quality factors for welding. If you have furnace butt weld, continuous welding, straight seam, then the joint quality factor is going to be 60%. Note 1 is the additional requirement that is given there. Electric resistance welding, 85%. Electric fusion welding, electric fusion welding is basically arc welding, okay? So single V butt welding, 80%. Spot radiograph, then it is 90. If 100% radiograph, then you can take this as 100%. Same thing with double V joints, 85%, 90% and 100%. 85% listed by this code. If it's a radiograph, spot radiograph, then it is 90%, and if it's 100% radiograph, then it is 100% or 1. Specifications: API 5L electrical fusion butt, double butt seam, straight or spiral. Required by the specification is 90%. If 100% radiograph, then it is going to be 100%. So stress range, these are creep damages. So these are basically damages which are, creep damages are basically damages that happens due to stresses coupled with high temperature services. So creep damage does not happen at room temperatures. Creep damage generally happens at elevated temperatures. So creep damage generally happens at 0.4 times the temperature. There is this temperature. It's 0.4 times the melting temperature of the material. So if the material is going to be melted at 1000 degrees Celsius, then at 400 degrees Celsius service, then it is going to be subjected to creep when it is worked in repeated cycles. Okay. Mechanical strength. For API 570 requirements of people who are studying for API ICP examination, pressure design is more important. We have to understand about pressure design. We have to understand about required thicknesses for sustaining the amount of pressure. We also have to understand that if we have thickness, then what amount of pressure it can sustain. Both of these things have to be done. For this, we have already talked about in introduction that there is a simple term. The API 570 approach is very simple in this. API 570 generally uses simplified Barlow formula for identifying thicknesses or pressures. But in ASME B31.3, it is more structured or more detailed approach where you are also taking temperature into consideration, and a variation on Barlow formula is given here, which is known as Brodmann's formula. Okay. So pressure design of the piping system. So generally the thickness of the piping system is going to be the thickness required for sustaining pressure plus some additional allowances. In most cases it is going to be corrosion allowances. So the thickness of the minimum thickness of the material is going to be the thickness required for sustaining pressure plus some additional allowances or corrosion allowances. Not just corrosion allowances, but other allowances also. Sometimes thread allowances are there, sometimes mechanical allowances are there. Most common is corrosion allowance. Okay. For straight pipe under internal pressure, When T is less than D by 6, then T is going to be done by P into D, where 2 SEW Py. Y is going to be achieved by this. P is the pressure, S is the stress, E is the quality factor, D is diameter. So you can identify thickness from this if the pressure is given. If the pressure is not given, if the pressure is given, you can identify thickness. If the thickness is given, pressure can also be found out by this. Okay. Same thing here. There is a variation on this formula. Both these formula are known as Brodmann's formula. For T greater than or equal to D by 6, or for P divided by SE greater than 0.385, the calculation of the pressure design thickness for straight piping requires special considerations of factor such as theory of failure, effects of fatigue, and thermal stresses. So you have to use this. If you're talking about API 570, there is a simple Barlow formula that is used here. Barlow formula and this Brodmann's formula are going to give you same results for lower temperature. Where the temperature increases, the deviations are very apparent. So whenever high temperature is taken into consideration, you generally need to be using a Brodmann's formula. This is this formula because it also takes temperature into consideration. If the temperature is not that enough, then you can simply use a Barlow formula, which is generally a simple modification on this. Okay. Straight pipe under external pressure. So joint strength reduction factors. So these are strength reduction factors based on the component temperatures. So as your component temperature increases, the strength of the material reduces. So this W, joint reduction factor, is based on the temperature, which is not taken into consideration when you are considering Barlow formula that was given in API 570. So when the temperature increases, if it's a high temperature service, then you have to use Brodmann's formula where temperature also taken into consideration, and weld joint strength reduction factor also needs to be taken into consideration. If it's a room temperature service, low temperature service less than 400 degrees Celsius, then in that case you can use a simplified formula or a Barlow's formula for that. Coefficient of Y. Now there are some design requirements that are given for different spools. So you have curved and metered segments of pipe, so curved, bend, or metered elbow. How to make them, it's written here. What should be the thickness, it's written here. What should be the inside diameter or inside radius is written here. How elbows are to be made is written here. How meter bends are made is written here. So designer all need to be taken into consideration of these things. These are meter elbow where 4 pieces of elbows are there and you'll be welding them as per the requirements. Curved and metered segments, branch connections, strength of branch connections, strength of welded branch connections, so these are some requirements that are given. This is for a nozzle or again a branch connection. So this is a branch connection. You have a main pipe and you have a branch connection going out from this. So how to make this branch connection, what are the welds to be taken done, what should be the thickness requirements, all of this is given here for the designer to take into consideration. Closures, opening in the closures, extruded outlet header nomenclature, blanks, reducers. Reducers are basically section where you have a high diameter piping that is connected to low diameter piping. The reducer section is known as reducer. So reducer section will generally increase velocity of fluid. So if you are making a reducer, then you have to consider these requirements. There can be a concentric or an eccentric reducer. Listed components, unlisted component. Next is fluid service requirements for piping components. So pipe includes the component designated as tube or tubing in a material specification when intended for pressure services. Specific requirements, pipe for category D services. Category D is basically non-toxic, non-flammable services. Again, who is going to say that the piping is going to be category D? The owner is generally going to be taking a decision that if the piping is a category D piping or category M piping or high purity or high pressure piping systems. So the pipe for category D fluid services, the following carbon steel pipe may be used. The following carbon steel pipe may be used only for category D fluid service, that is API 5L continuous welded ASTM A53 type F, ASTM A123 made from other than ASTM A285 plate, piping requiring safeguarding when other than category D fluid services, the following piping shall be safeguarded. The limit are given here. Pipe for severe cyclical services. These materials can be used for cyclical services for API 5L, or other requirements are given in table A1A and A1B. Elevated temperature services. In elevated temperature fluid service, all longitudinal and spiral welds in P number 4 or P number 5 materials shall be examined 100% radiography or 100% ultrasonic examination. Acceptance criteria are stated in paragraph 341.3.2 and table 341.3.2. So, if you have elevated services and if you have a longitudinal weld seam or a helical weld seam, then both of these weld seams are going to be 100% radiographed or 100% ultrasonically tested. Acceptance criteria are given there. Fittings, bends, meters, laps, branch connections, how to make them. Fittings for severe cyclical services, only the following fitting may be used under severe cyclical services: forged, wrought, seamless or welded. If welded, requires 100% radiograph of welds in accordance with paragraph 344.5.1. Cast with a factor of casting quality greater than or equal to 90, and fittings conforming to MSS SP 413 and MSS SP 119. Pipe bends, meter bends, laps, forged laps, laps with severe cyclical conditions, thermovalves, valves, flange facings, blanks and gaskets. Generally flange, especially if you're talking about cast iron flanges are not generally made, they are selected, and there is a standard for that which is known as ASME B31.3. People who are studying for API ICP examination generally know what is ASME B31.3. We'll talk about this when we go about solving some problems on the selection of flanges. But again, the flange should be selected based on the materials of construction and the pressure rating. Requirements for flanges: boltings. Generally, two kinds of joints only can be made. You can have a riveted or a bolted joint, or you can have a welded joint. Where you don't need a permanent joint, you generally do bolting, but bolting is generally not preferred for high diameter piping system. It is generally preferred for low diameter or low nominal pipe size, small diameter piping basically, small bore piping also known as. Tapped holes. Fluid service requirements for piping joints, welded joints. Backing, consumable insert, socket welding, fillet welding, seal welds. Seal welds are basically welds. Let's imagine if you are doing threading for any connection. So after threading, you can weld it and it can be sealed shut. That is seal welds. Generally done for preventing leakage from the threaded joints. Flange joints. Metal to non-metal flanges, expanded joints, threaded joints, tubing joints. Multiple things are there. Flexibility and support. Specific requirements, concepts, displacement strains, allowable stresses, flexibility, bends. So these are multiple bends are done. So these are degrees of freedom for the pipe bend joints. Analysis of sustained loads, stress due to unsustained loads, piping supports. You can have multiple supports for piping system. You can have braces, brackets, dead legs. You can have dummy legs. All of these are supports. Dead leg is not a support. Dummy leg is a support. Fixtures, materials, counterweight, structural connections, systems, pressure relieving systems. Pressure relieving systems are going to be pressure relieving devices. In most cases, it is going to be a pressure relief valve. Pressure relieving discharge piping, pressure relieving devices. And that's it. So in this video, we have talked about chapter 2, which is design and design criteria for ASME B31.3 piping systems. These requirements are generally not that important for the people who are studying for ICP examinations, but if you just want to know about a piping system, then this provides you with most of the information that is needed or that are recommended for the designer to design a piping system that is going to be competent for the service it is intended to. Okay, that's it for this video. In the next video, we'll be talking much more about chapter 3 or the materials that are going to be used for construction. That's it for this video. We'll meet in the next video on our same series of ASME B31.3 process piping systems. Thank you.